Okay, in this section 2-9, the topic here is polynomial inequalities. And so the first main point that we want to get into here is that starting with this statement right here, it says the inequality f of x less than 0 is true when f of x is negative, right? So the inequality f of x is less than 0 is true when the function itself is negative. And then likewise, the other way around, f of x is greater than 0 is true when f of x is positive. Now, the easiest way that we can analyze that is by looking at the graph, and that's what this shows right here. Now, it can be done algebraically, okay, but the easiest way to do it is to take a look at the graph. Okay, so let's kind of take a look at these bullet points that we have here. So f of x is less than 0. So let's look at this particular graph and see where f of x is less than 0. Here are the intervals from -4 to -2. So from here to here, that's where it's 0, or that's where it's negative, less than 0. Okay, so union together with from 2 to 5. So from 2 to 5, it's less than 0. And of course, then from 5 to infinity is the third section where it's less than 0. Now, here's the deal. Since this is strictly less than 0, 5 cannot count. So this is why this is separated into two separate intervals, because 5 itself doesn't satisfy the inequality. 5, or right there, it's equal to 0, not less than 0. Now, let's see how this one differs from the next one. F of x is less than or equal to 0. So now it can be equal to 0. So on this same interval from -4 to -2, but notice the difference. On the one where the function was strictly less than 0, 4 and -2, those points where it was 0 didn't count, and thus it had to be in open parentheses. However, if the function is less than or equal to 0, then at 0 that still satisfies the inequality, and so -4 and 2 would count as solutions to that inequality. And so now we need the bracket indicating that -4 counts and 2 counts. So that's kind of the difference between just less than and less than or equal to. Now, look at this other interval. The other interval where it's less than or equal to 0 would be from 2 all the way to infinity, just that 1 0. We don't have to exclude 5 anymore, because at 5 it's equal to 0, so it's not, it still satisfies the inequality. So you can actually just write that as one interval instead of having to separate it into 2 like you did when it was just less than. Because here we had to exclude 5, so we had to separate it into 2 intervals. Here 5 is included in the solution if it's less than or equal to 0. Because now we're just excluding parts where it goes strictly above 0, and it doesn't go above 0 here. So this whole thing is just one big continuous interval, to whereas here we had to split it up. So make sure that you keep that in mind as you're going and answering these questions. Just make sure that you are writing out the interval correctly. All right, f of x equals 0 at these 4 points. Those are the 4 points when it's actually equal to 0. Now, on the other hand, let's go greater than 0. Well, it's greater than 0 from -infinity to -4, not including 4, because that's where it's 0, unioned with from -2 to +2, again, excluding those values. We got the parentheses, because that's where it's 0. And it's greater than or equal to 0 from -infinity to -4 is where it's greater than 0, but including 4 this time, because equal to 0 is okay. And then from here, from -2 to 2, including those 2 values. But remember, we had to add this on because there's one more point where it is equal to 0, and that's at 5. And notice it's in brackets, not parentheses, because we are including that value of 5. So if it's just one particular value that you're going to include, because it touches at 0 there, and it's equal to 0 is part of the inequality, then you're just going to put that one value in a set of brackets. All right? And so this is kind of an example of how we can write out the intervals based on whichever inequality we have. So again, if you graph it, then you can tell what the different intervals would be, whether it's greater than or equal to 0 or less than or equal to 0 or whatever it is that you're looking for. Now, on this first one, okay, it says to solve this inequality. The first way we're going to do this here is I'm going to show you how to do one of these algebraically, and then we'll go through it graphically. All right, so when you want to solve these things, now the first thing that you want to do is set one side to 0. So I'm going to move the -3 over to the other side. So when I do, that will be x squared minus 6x minus 27 is greater than 0. Okay, is greater than 0. All right. And so now when we take a look at this, from here we can actually go through and factor it. So we'll do that next. So this will be x and this will be x. Go ahead and write my signs in here as positive times a negative equals a negative. Now, two numbers to multiply to give me the -27, but at the same time they combine to make -6. We'll go 3 here times 9 here. I wanted my 9 to be negative, so my term in the middle would be negative. 3x minus 9x is -6x. Okay, now, to finish solving this algebraically at this point, we want this times this to be greater than 0. This times this to be greater than 0 is what we want. All right, so when we're looking at this now, the way that we can finish solving it algebraically is at this point we need to draw ourselves a number line, okay, with the points of interest on here. Okay, and so if this is x plus 3, then my first point of interest would be -3. All right, so -3, we'll put that there. And if this is x minus 9, the other point of interest would be 9. All right, so these will be the places that it would possibly change from positive to negative, right? So the next thing that we want to do is we want to plug in a value in each of these intervals and see if the product of those two would then be positive or negative, right? So for example, let's say I just came here and I picked -4. All right, so -4 is less than 3, right? -4 is less than 3. So I'm going to go ahead and circle these points too, by the way. All right? And since I know that it's strictly greater than 0, I'm going to leave these as open circles. If it was equal to, then I could fill them in, right? But I want it to be strictly greater than 0. So if I plug in 3 here, or -3 here, and make that 0, then it wouldn't count, because it's got to be strictly greater than 0. So let's plug in -4. Let's say I plug in -4. So -4, right? -4 plus 3, okay? -4 plus 3 is a -1, right? So that'd be -1. So that's a negative, right? And then if I plugged in -4 here, that would also be a negative. So if I plug something in that's less than -3, both of these would be negative, and negative times a negative makes anything that I plug in this region positive, right? Anything I plug in that region would be positive. Because like I say, -4 plus 3 is -1, and -4 minus 9 is -13. Negative times a negative make a positive, and so anything that I plugged in this region on the number line would yield a positive result, right? Now, let's pick something in here between -3 and 9, like 0, let's say. If I plug in 0, then that's a positive result, right? If I plug in 0 here, that's a negative result. So positive times a negative would yield a negative number here, right? So anything I plug in between here is going to be negative. Anything I plug in between here is going to be negative, right? So even if I came all the way up to 8, positive, 8 plus 3 is positive, 8 minus 9 is still negative. So anything in between here is going to be a positive times a negative, which yields a negative result in here. Negative number would be less than 0, not greater than 0. And here, let's go with 10. 10 plus 3 is positive, right? And 10 minus 9 is also positive. Positive times a positive. Anything here that I plug in would yield a positive result. Now, let's see if we can use that to answer the inequality. I need this product to be greater than 0. So what intervals would cause this product to be greater than 0, so it'd be anything here and anything here. Well, what's this interval? Well, this is from anything I plug in from negative infinity to negative 3. Remember, we need a parentheses because it can't be equal to 0, strictly greater than. And I need to union that with anything from 9 to positive infinity. Okay? And so that's how you would answer or solve one of these polynomial inequalities algebraically by using a number line to help you finish it. However, it's much easier to solve one of these graphically. And so now I can kind of show you what that looks like. If we pull up our little Desmos calculator here, we can see that if I go ahead and plug this thing in, and I can just plug it in y equals x squared minus 6x and then minus 27. You need to plug it in where you've already had it one side set equal to 0 when you do this. All right, so as we can see now, when we take a look and see where these points are, still negative 3 and 9 are my points of interest, just like they were here. But look, where is the graph greater than 0? Well, the graph is greater than 0 or above the x-axis from negative infinity all the way up to negative 3, which that's the first interval we got, and then also from 9 up to positive infinity, which is the second interval we got. So again, when you're looking at the graph, you want all parts of the graph, all intervals of the graph where the function is greater than 0. Well, where is it greater than 0? Then up above the x-axis, which is this first interval and then that second interval. So it's much faster and easier to get the result by graphing, right? So that's what we'll do for the rest of these examples. And as a matter of fact, this next one that we're looking at is already solved for 0 on one side. So really, all I have to do at this point is just start graphing. So I'm going to jump back in here and I'm going to switch it to 2x to the third power plus 7x squared minus 12x minus 45. And so here is my graph. Let me double check, make sure I plugged everything in correctly. Okay, it looks like I have. All right, so now, what do we want? We want all places where this particular graph is greater than or equal to 0. Greater than or equal to 0. Well, if I start looking at it, I see equal to 0 right here at negative 3. So remember how we put a single point in there? We put negative 3 in a set of brackets to denote that it's equal to 0 right there, which is okay for our inequality that we have on this one. Now I'm going to union that with another interval, and that would be the interval from 2.5 up to positive infinity. So here's where it starts going positive again, and then it goes positive from here on, from 2.5 on. All right? So you could write that as 2.5 if you wanted to, but probably more commonly you would see that listed as 5 over 2. Could be either way though, and infinity. All right? And remember, 2.5 gets a bracket because we're looking for anything greater than or equal to 0, and it's equal to 0 at that value. All right? So once again, much quicker and easier to just graph these and come up with these solutions and the correct intervals that way. Let's look at a few more then. All right, so here, this one is already set equal to 0, or set, shouldn't say equal to 0, set to 0, because that's not equal. Okay, it's already set to 0 on one side, so I'm just going to go back into my graph and change what I had there. And so let's take that off, and we're going to change this now to, oops, y equals x squared plus 2x plus 5. All right. So here's the question. We want to know, where is this less than or equal to 0? All right, so by looking at the graph, where do you think that this thing is less than or equal to 0? Nowhere. Okay, it's not less than or equal to 0 anywhere. Okay, now we're not going to write the answer as no solution, because no solution is typically used when there is an equation that doesn't have an answer to it. Nothing to satisfy the equation. There's no solution. But remember, this is an inequality, so we're more like talking about sets of intervals. And so really, when you've got an inequality where no intervals fit it, you will use this symbol, which is the symbol for the empty set. Empty set. Okay? That indicates that there is no interval that can be used as a solution for this. All right? Empty set is what you'll see, or sometimes it's called the null set. All right? Okay, so when you see that, then that's the symbol for the empty set, meaning that there's really no intervals that would work as a solution to the inequality that you have, right? There's no place on this graph where the function is less than or equal to 0. So it's not less than 0, and it doesn't even hit the x-axis, not even equal to 0 anywhere. Next one, we got to do some rearranging first. So I'll go ahead and move this negative 16 over to the other side, change it to positive. When I do, I'm going to get x squared minus 2x plus 1 is less than or equal to 0. And now that I have one side set to 0, I can come back and graph it. So I'll take the old one off here and change it to the new one, which is x squared minus 2x plus 1. We've got our graph here. Now we're looking for the place where this is less than or equal to 0. All right, well, it's not less than 0 anywhere, but it is equal to 0 at that point. So there's one single value in the solution set, and that one single value is 1. All right, so there's your answer here. Let's go to the last one. Again, we will have to rearrange it. However, notice there's only one difference between this one and the next one, and that's just the symbol. So instead of greater than, less than or equal to, then we're going to have greater than. So let's see how that affects it. If you've got the exact same thing, but the symbol's changed. Let's see what happens here. So that's still going to be plus 1. And we're going to have that as greater than 0 this time. So I already have the graph. I don't have to change the graph at all. I can just look at the same graph. And so we want to know where this thing is going to be greater than 0. Well, it's greater than 0 everywhere except at 1. So how are we going to denote that? Well, from negative infinity to 1, but not including 1. Let's get a parentheses. We're going to union that with everything from 1 to positive infinity. All right? And so there you go. So like I say, easiest way, graph it, and then you will be able to come up with your solution to the polynomial inequality.